So you might be thinking, can I really just make up a new number? Is this a legitimate step? What set of numbers includes both real numbers and imaginary numbers? What do you get if you add a real number to an imaginary number? Is that another kind of number? Well, when you were a little kid, you started with the natural numbers. And then in elementary school, you extended the natural numbers so that you started working with a larger number set that included the naturals, 0, and the additive opposites of the naturals. This gave you the integers. And you learned how to do all kinds of math with integers. And then you extended your number set to include all numbers that can be written as a ratio of integers with a non-zero denominator. So this gave you the rationals. And then, when you thought you knew all the numbers that existed, you learned about numbers like pi and the square root of 5. And so you extended your number set to include all the numbers on the real number line. Well, when you ask the question, what happens when we extend the real numbers to include the square root of -1, the answer is we get the complex numbers. So the complex numbers are defined as numbers of the form a plus bi, where a and b are real numbers. There are two kinds of complex numbers. There are complex numbers in which b is equal to 0, and there are complex numbers in which b is not 0. So complex numbers in which b is equal to 0 are just real complex numbers. In other words, real numbers. So any number on the real number line is of this form. And then if b doesn't equal 0, we have non-real complex numbers. Numbers like 3 plus 4i, the square root of 2 minus 1/5 I, or -7 plus pi I. In other words, the I part of the number is non-zero. So the important thing to remember is the complex numbers are a superset of the real numbers. Real numbers fit inside the complex numbers. So now we're going to learn how to do arithmetic with complex numbers. In all of the exercises that follow, you are asked to start by writing out the statement. So you're given complex numbers defined in this way. You have a complex number w, which equals 5 minus 3i. You have a complex number x, which equals 10 plus 7i. And you have a complex number y, which equals -2 plus 8i. And then you're asked to add these numbers or multiply these numbers or subtract these numbers. So here's an example. When we add w plus x, we add 5 minus 3i to 10 plus 7i. And the way that we do this is we add the real parts and the imaginary parts separately. So when we add 5 minus 3i to 10 plus 7i, we add 10 plus 5, and then we combine -3i and 7i, and this gives us 15 plus 4i. And then next we calculate the product xy, where x is the complex number 10 plus 7i, and y is a complex number -2 plus 8i. So what's important to remember here is we use the distributive property to multiply complex number in the same way that we multiply binomials. So it's a little bit difficult to follow how the distributive property is being used here. So I'm going to make a little expansion box that will allow us to better organize our work. We'll write it this way. So we have -20, -14i, 80i, and then we have 56i squared, which we know is the same thing as 56 multiplied by -1, negative 56. So that's what I'm going to write in this box. So when I add negative 20 and negative 56, I get negative 76. And when I add 80i and negative 14i, I get 66i. And we can see that that matches what we get here. So I encourage you to create expansion boxes if that helps you. All right, let's go through some of these together. So again, you just need to practice writing out the complex numbers. So that's why we have them. Instead of the complex numbers already written out for you, we have them written this way, like w plus y, x minus w, y minus x. This is just so that you get a little bit of extra practice. So don't get thrown off by that. So since we're wanting to add the complex numbers w plus y, we're adding 5 minus 3i plus negative 2 plus 8i. So we add the real parts, 5 and negative 2, to get 3. And we add the complex parts, the imaginary parts, negative 3i and 8i to get 5i. So next, we calculate x plus y, so we add 10 plus 7i and negative 2 plus 8i. When I add the real parts, I get 8. When I add the imaginary parts, I get 15i. Next, we calculate x minus w. So remember, we're subtracting both the real and imaginary parts from 10 plus 7i. So this is going to be 10 plus 7i minus the quantity 5 minus 3i. So we distribute negative 1 to each of those parts, which gives us 10 plus 7i minus 5 plus 3i. Then I add the real parts to get 5, and I add the imaginary parts to get 10i. Then here, y minus x, start by writing negative 2 plus 8i. Then I subtract the entire complex number, 10 plus 7i, which means I distribute negative 1 to each of these parts. So I get negative 2 plus 8i minus 10 minus 7i, which gives me negative 12 plus I. Then here, I'm multiplying the complex number x by the complex number w. So I'm multiplying 10 plus 7i by 5 minus 3i. And if I create a little expansion box, this will be a little easier to do. So I get 50, 35i, negative 30i, and negative 21i squared, which is negative 21 multiplied by negative 1, so that is positive 21. Then I add the real parts to get 71. And then I add the imaginary parts to get 5i. So this is 71 plus 5i. And then here, when I calculate w plus y, I'm multiplying 5 minus 3i by negative 2 plus 8i So let's create a little expansion box here. I get negative 10, 6i, 40i, and then negative 24i squared, which is positive 24. Adding the real parts gives me 14, and adding the imaginary parts gives me 46i.